Binary Arithmetic, Module 1. We're going to follow chapter number 7 of this book, and I'm providing the PDF on Canvas. We're going to cover addition and subtraction of binary numbers. Then we're covering another set of numbers, BCD numbers, and we're going to see what is the sign and unsigned way of representing binary numbers. Before we go over additions, just a little bit of an introduction. We are dealing with the brain of the system, the computers, the digital logic that it's inside of these ICs. Information is exchanged between ICs by using base 2, binary numbers, zeros and ones. We can also use base 8 or 16 to condense that binary information. And now we know that those ICs or those computers, they only perform addition, subtractions, multiplications, and divisions. So let's see and cover addition for now. Let's go over simple addition. Let's see how it works in decimal in base 10. If I have 8 plus 9, I know that the result is going to be 17, and 17 exceeds the number that I can put on this first place over here. So what I do is I put the 7 and I carry the tens into the 1 into the tens column, and then I do 1 plus the other zeros and you get your answer. So if you understand base 10, base 2 is going to be the same way. It's just that you overflow faster because you can only represent two numbers, either 0 or 1. So let's see some simple rules. 0 plus 0 gives you 0. 0 plus 1 gives you 1. And 1 plus 0 gives you 1. Nothing extraordinary here. I'm not overflowing anything. My result is either a 0 or a 1, which I can represent in this base. So everything is fine. But what if I have 1 plus 1? The result should be 2. But I can only represent up to 1 in this place here. So what happens here? Well, I get a 0 and I carry the 1, and now I add 1 with zeros, and here you go, you get your 2. Another example is if you have your 1 plus 1, but now you carry the 1 from a previous addition, and the result of this should be 3. So how do I operate here? I group these two ones together first, so 1 plus 1 gives you a 0 and carries the 1. And now this one goes down. And now this 1 plus zeros gives you 1. And here you go. You get 3. So one more time, really quick. I pick up these two ones first. And I apply the rule that we just did over here. Gives me a 0 and I carry the 1. And then 0 plus 1 gives me 1. And that 1 carries down. This is called simple addition. Now let's see if we can perform this one. Let's plug more bits together. So pause the video, give it a try, and I'll show you the solution in a bit. So how do you solve this one? We'll start by doing this first part over here. 0 plus 1 gives me 1. And 1 plus 1 gives me 0, carries the 1. And 1 plus 0 gives you 1. And here you go. That's your answer. You can always convert to base 10 to see if your answer is correct. So in this case, I get a 2 plus a 3. I need to get a 5, and that's what you get. Complex addition in binary, it's just this. Adding more bits and propagating those carries so you can do the additions of binary numbers. So stop once again the video. Go over this one and then check the solutions. So let's do it this one. 1 plus 1 gives you a 0 and carries the 1. 1 plus 1 gives you a 0 and carries the 1. Now I can do this 1 goes down, and I just focus on these two ones. Give me a 0 and carry the 1. Same thing applies here. And I carry the 1. 1 1 and 1 gives you a 0 and carries the 1. And the same thing here. 1, 1, 0, carries the 1, and it goes down. How do I know if this is correct? Once again, go to base 10. We have 47 plus 29 needs to give you 76, and you get the right answer. Example number 2. Give it a try on this one. Stop the video. And once you give it a try, this is going to be your answer. Once again, base 10, 29 plus 37, and you get 66. In the computer, the addition of binary numbers is performed by a special hardware unit called Arithmetic Logic Unit, or ALU. And normally the ALU gets two inputs, A and B, with a certain amount of bits and produces a result. And you normally can perform additions and subtractions. So there is another input that you can tell the Arithmetic Logic Unit to perform either an addition or subtraction. And once that operation is done, the ALU raises an LED or a flag saying like everything is done.